So not all image classification will be 100% correct. Actually, very few classification is also be 100% correct. Every classification product will have some error in it. Okay, so then how do you figure out how much error is in my classified product? So for that, we actually do field data. And again, this is in the context of natural resource application. So we need field data or ground data. And so we go out in the ground and, we see things, and then we record the location of that location by using a GPS. And then also we want to use the location that are representative of the things around it. Okay, so we don't want to go take points on an edge, at least for image classification. We can take it for another reason, but when you want to do image classification for land cover type or bone severity, we want to go to a location where things are pretty much similar all around that location, and we take the location or store the location using a GPS. For the area of interest, we want to have a pretty good coverage, so we want to go, have our field data collected in such a way that it's all spread out within the area of interest. Okay, so that's how we go and collect field data, and we note down everything that we see that will have an influence on our interpretation. Okay. And once you have a good number of data points, and of course, if you have a huge area, then you might want to collect a lot of points. If you have a smaller area, then you might want to collect less points, and so on. And then once you have all the points collected from the ground, I think a good rule of thumb is that 70% of that data point can be used to create training polygons. Okay, so you can sort of randomly set aside the 30% of the points for later accuracy assessment, and then use the 70% to create training polygons, because since you are on the ground, you know what exists around those points. So then you can draw polygons around those points, and those polygons will be your training polygons for different classes. So for example, if you're doing vegetation, so then you want to draw polygons around the conifer points and use them as a conifer training polygons. You'll go draw polygons around your deciduous points and save those training polygons as your deciduous training polygons, and so on. Okay. So once you have all your training polygons created, you will run your image classification like we did last Monday, and you have your classified product. Okay. Now, once you have your classified product, then we want to use our 30% of the data that we actually didn't use for training to assess how good our classification product is. So again, we're looking at the schematic that we used last time with 3 classes: water, urban, and vegetation. And the white dots represent the distribution of our fill points. Okay, so those are the distribution of our fill points. And then, so for those field points, we actually know what exists on the ground. Okay, so we know what exists on the ground because we actually collected those points, right? And then we also have a classified map that identifies those pixels as one of the land cover classes. Okay, so you have two sets of data set: one collected in the ground, which is truth, and then a classified map, which is a sort of a prediction that what that pixel class belongs to. Okay, so once you have these 2 data sets, then we can create something we call confusion metrics or error metrics. Okay, so here we are getting data from 2 places. One is our field data, the other one is from your classified image pixel. Okay, so now how do we actually make sense of a table like this? So we're again talking about a simple example with 3 classes: urban, vegetation, and water. And in the column, we have the true points. So in the urban column, what we have is there are actually 70 points where we actually saw urban. okay, or 70 ground points for urban, okay? And in the image also, it looks like all those 70 points are correctly identified as urban, okay? So the column is the truth and row is the prediction, okay? So if you see, that's the urban column, that's the urban row, and we have 70 here, and also the column total is 70. What that means is that we actually collected 70 ground control points for urban, and for all those 70 points, our image also identified them as urban. So that's why for this particular class, the accuracy is 70 over 70, which is 100%, okay? Now for vegetation, the situation is a bit different, okay? So the column is the truth, right? So we actually have total 50 ground control points for vegetation, okay? Total 50 points for vegetation. Out of those 50 points, looks like 37 were correctly mapped as vegetation, okay? But the remaining 13 are actually mapped as urban, okay? Because in the row, we have 13 in here, okay? So what happened in case of vegetation? Well, we had 50 points, but out of those 50 points, 37 are correctly identified as vegetation, and the remaining 13 are incorrectly mapped as urban. So what is the accuracy for this particular class then? 37 over 50, which is 74%, okay? Anyway, and then for the water, again, we are in luck. We had total 121 points, and all 121 points are correctly mapped as water in our image. Okay, so for water also, the accuracy is 100%. So this is how we find out the accuracy for individual classes, okay? And how do we find out the total accuracy? So the total accuracy will be if you take the number along the diagonal, right? So 70, 37, 121. So you take the sum of that divided by the total number of points that you have, okay? Which in this case is 241. So that gives you the overall classification accuracy, okay? So we talked about individual image classification accuracy. We talked about overall image classification accuracy, okay? And then we have two more errors that we need to talk. So we talked about vegetation, right? So in case of vegetation, what happened is that out of 50, 37 are correctly identified, okay? So 13 are incorrectly identified. So if you, for vegetation, we have 13 over 50, which is 26% omission error. That means 26% of our vegetation area are underclassified. That's what it means. Omission error means underclassified, okay? And then 13 of our actual vegetation is mapped as urban. So 13 over 83, that tells us that we have 15.6% commission error. That's for the urban class. That means in our classified map, about 16% urban is overclassified,